All right, hi everybody. So what we're going to look at today is uncovering this mystery of how electric guitars work, part 2. So part 1 was kind of what we did yesterday. We kind of started to build up this idea about ferromagnetism and paramagnetism, and then diamagnetism. So what we're going to do today is we're going to look at some of your ideas about how electric guitars work, 4 of your ideas for the 4 people who responded, so thank you to those 4 people. And then we're going to kind of build up these 3 truths that we can kind of accept or notice or see based on our prior information or new information. And then after those 3 truths, those 3 ideas, we'll have a working idea and we'll be able to have enough information to discover how an electric guitar works and kind of put that together ourselves, which is exciting. Some things that I'd like you to do, these are just kind of new things. Or not new things, sorry. These are kind of not new things. So we got some stuff on AP Classroom to do. I posted that, 2 days ago. And I have some video solutions in there. So it's good practice to kind of wrap up that prior learning about magnetism, everything we did the week before we left for school. And then if you could fill out that form about office hours, I held a Zoom session today and I felt like it went pretty well. So I'm excited to try out office hours in that same Zoom format. So I want to know what hours work for you so that I can get the most amount of people in there. Of course, I'll still record it and I'll post that recording, but I want there to be enough for a lot of people. And then what we're going to do today is at the end, I'm going to ask you to create a video explanation using this new kind of software that I want to try out. And yeah, so we'll see how that goes. I don't have that made yet, but I'm going to make it in between these videos and then see how that happens. So yeah, first I want to look at your ideas. And let me just check to make sure we're recording. We are recording, great. So your ideas so far, so the 4 people who responded, thank you. We're saying, okay, so how do we think electric guitars work? We're going to use magnetic induction to move a diaphragm type device and a magnetic coil to create sound. That sounds great, that's a perfect idea. But I want to know, what does this induction mean? What is this diaphragm type device? What does magnetic coil have to do anything? How do we make sound? What's all that? So we got the right ideas, then we're going to dive deeper into what's going on here. Strings are made of steel, which is ferromagnetic. That's going to be the first thing we're going to be looking at today. They stay magnetized, awesome. So applying that definition of ferromagnetism, strings have a magnetic field because they are magnetized, and there's a flow of current that can now move. So we got this current, since they're magnetic field and a current, there's also a force between, because of the right-hand rule, the force makes the current move in a particular way, which creates oscillations in sound. More parts of guitar that I don't know about. Cool, awesome. This one I like, so we're saying there's current running through each of the strings. This is a really interesting idea, but if you were to pluck one of those strings, you may get electrocuted, which would be a bummer. But I really like the idea here, how we're thinking about these strings as wires. It's a good idea. The current creates a magnetic field that acts upon the other strings. Because the strings are ferromagnetic, they hold their magnetic field. Magnetic field flows down all of the wires. Small circular magnets underneath the strings serve to strengthen this magnetic field. And when a string is struck and vibrates, using the right-hand rule, the current running down the string in the magnetic field to the right creates a force perpendicular to the guitar and sends vibrations far away quickly. So it makes it loud and cool sounding. Nice, all right. And then the strings take on magnetic properties, and the guitar has an electrical current running through the pickup, creating a magnetic field. Now when the string vibrates, the pickup can record its vibration and send that to an amp to be amplified. Awesome, so we're using that again, idea that the string is taking on these magnetic properties. And that's great, so that's really going to be like the first truth that we're looking at, the first main idea, the first thing that we want to examine. So once this loads up. So the first truth, the first thing that we need to accept if we're going to have this, is this idea that, okay, these electric guitar strings are made of steel, which is ferromagnetic, like a lot of you said in your responses, which means, I'm going to go over to OneNote really quick and kind of draw this, that if this is our the little magnet that's down there on the bottom, it's like these little magnets, we say, oops, not OBS, there we go. We say, okay, well, this has a magnetic field around it, and then it's going to be kind of like that going south to north. So that has a magnetic field. And then we said, hey, there's a bunch of little electrons in this metal, and these electrons can have this spin to them, and they can become oriented in a certain direction. because this string is steel, it's ferromagnetic. So we can get a bunch of these little electrons pointing in this direction, and we can get this net dipole moment, just like we talked about yesterday. So now we have this string. I'm going to get rid of this really quick. Oops, I got rid of too much. So it doesn't matter too much, but so now we have this string that absolutely it has a magnetic field to it. So we have this magnetic field that can then move around because this string moves around. So really what these magnets are doing down here is they are inducing this magnetic field in that string, in this steel string, and now we have a magnetic field that can move around when our string is moving up and down and oscillating. So that's really the first thing that we have to accept, is this idea that our string became magnetic. This is gonna look a little weird, but it's okay. I think I told you guys a few times, I do not play the electric guitar, I don't pretend to play it. But in middle school I thought that I wanted to, so I bought one. And I'm not good at it, I don't know how to play it well. But I do have it right here, thankfully I brought it home. And I also have a magnet, so just kind of proving it to you. I don't know if it's strong enough to stay. Yeah, it's definitely not strong enough to stay. Oh, you can't even see what I'm doing. Oh, there we go. Hey, it is strong enough to stay. So these strings, even though they're not super strongly magnetic, and also it's kind of a function of this refrigerator magnet not being very strong, this is a magnet. So these strings are magnetic. I had you here. In real life you could just kind of do it and feel it, but so these strings are magnetic. So that's kind of our first truth. They're made out of this ferromagnetic material, which means that they have the ability to be magnetic because they're brought by the strong magnet. So that's kind of what we have so far. That is our first truth, this idea that we have these magnetic strings. So that's the first video. Then I'll see you in the second one where we're going to look at that second truth.